Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 525 Contiguous Array. This is a medium difficulty Leetcode problem, and in this problem we're told that we're given a binary array nums and we want to return the maximum length of a contiguous array with an equal number of zeros and ones. So we're given an example, and in this example over here we have the array is already balanced, so the longest contiguous subarray is the length of the array itself, and that is 2. Over here, in the second example, the longest contiguous subarrays are either 0 and 1 or 1 and 0. If there was another 1 after here, then it would be a length of 4, but right now it's just a length of 2 because these are the only two contiguous subarrays with an equal number of zeros and ones. So how are we going to solve this problem? Well, if you've solved a lot of Leetcode or array problems before, you might think, okay, this is a sliding window problem. So let's say we have 0, 1, or actually let's say we have 1, 1, 1, 0, 0, 0. This is our subarray. That doesn't look like a good 0 at the end there. So I'm going to draw that again. Okay, so this is our subarray. Well, let's use a sliding window technique is what we might say. And so we'll get to, we'll keep increasing our sliding window until we get to 0. And then we'll check, is it balanced? No, it's not. So let's keep going. Let's keep increasing our sliding window. Boom. So now we've found this sliding window where in this window, all of the numbers are balanced. We have the same number of zeros and the same number of ones. But wait, we've only found 1, and there's more windows actually. We could have 1, 1, 0, 0, or we could have 1 and 0. So we're just skipping over these numbers. We're just skipping over a bunch of numbers. And although we may find a single contiguous subarray, or maybe we'll have multiple, we're missing out on actually catching some of those other contiguous subarrays. And so you might say, okay, how do we know when to shrink or when to enlarge our window? How do we know, when to remove a 1 or when to remove a 0? If we had the power of hindsight, we could, if you could see in the future, we would say, let's not remove this 1 because this 0 will come eventually, but we don't have that capability. So we have to make a decision early on whether to remove a 1 or 0. And if we do, even if we remove this 1, or even if we don't remove this 1, sorry, we won't find out these subarrays which are nested. So we would have to use a recursive solution, which would be big O of n squared anyway, and that would be the same as just brute forcing and going through the entire list anyway with the two for loops. So really, that's not an efficient solution either. So we can't use a sliding window for this problem. What we can do, however, is use a prefix sum and hash map solution. And I've actually gone over this problem before, I believe in Leetcode 560, and actually the Leetcode video that I did yesterday, which went over a problem analogous of this 560 with kind of the same solution using a prefix sum and hash map. So how are we going to solve this problem? Well, let's kind of look at the logic here. We've got 0 and we've got 1. We know that they balance each other out, but how could we make this easier for ourselves? We could say, let's convert this 0 into -1. So all zeros are converted into -1. And then we can say, well, what's 1 plus -1? Well, we're just going to get 0. And so we'll know that a subarray is contiguous if its sum is equal to 0. But how can we actually solve this? Again, by using a prefix sum and hash map problem. And I'm not going to go into the specifics of it, but basically in this problem, we're going to have each count mapped by an index. So the count is going to be the difference. So let's say we have, 1, 1, 0. So the difference here, or actually we can say -1, 0, minus 1. So these two can't, oh, actually, this is wrong again, negative 1. So these two cancel out, we see we'll get 0, but here we'll end up with negative 1. So we want to map out, this count is actually, it probably would be better to call it the difference, but we're just going to call it the count, and the count is going to be basically where does this happen at index 2. So if we come across a, minus 1 again, well, we'll know negative 1 and negative 1 will cancel each other out. And we know that basically all the numbers in that range will also cancel out. They'll all be balanced. We'll have the same number of zeros and ones in that subarray. So that's how we're going to solve this problem, and that's how we're going to store the numbers in our hash map. So let's actually get to coding. The first thing we're going to do is set a count equal to 0, a result equal to 0, and a hash map. Initially, it's going to have 0 mapped to negative 1, just so that if we have the edge case of where we have 0 or we have negative 1 initially, we'll be able to be that edge case as well. So let's say we have for I in range length nums. We want to increment our count by 1 or by n, and we actually specify n as being nums I, but we don't want to just increase it by nums I, do we? We want to say 1 if nums I equals 1. Otherwise, instead of 0, we want to increment our count by minus 1. So we want to subtract negative 1 basically. We want to say if the count is in the hash map, well then let's set our result equal to the maximum of our result and the index minus, or the current index minus the hash map, the value we have in our hash map, so minus count, and that will give us basically the entire subarray length, and set that if it's greater than result. Otherwise, if the numbers don't cancel each other out, they may do on the next go, so we'll set the current count equal to the current index, and then simply return our result. So let's submit our code. And we can see that we passed all 565 test cases. And so I hope this video kind of made sense, and the intuition behind it made sense. It is a bit confusing to solve. I think a lot of people do go in with a sliding window technique and they kind of just ignore the prefix sum and the hash map because it's, again, a bit hard to spot. And there are other ways to do there are other hash map solutions. We could, have, instead of calculating a count, we could count the number of zeros and the number of ones, and then, it would make more, it would be easier to code, I guess, and maybe a bit longer, but easier to visualize. But the prefix sum and hash map solution, if you know how the technique works, is optimal to solve this kind of problem. So in terms of time complexity, it's going to be big O of n, and because we have a hash map, worst case scenario, it's also going to be big O of n. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.